Good afternoon, students. Good afternoon. Can you see the screen? Can you hear me? Anybody? Just checking before we start. Hello.
Yes, sir.
Thanks. All right, guys. Let's see if we can have a nice, quick, and efficient session this afternoon. So I got solutions from a number of persons, which was really good to see. Still not getting work from a number of persons, but going forward, we will have to change that. All right. A lot of the papers that I'm doing now, you're actually going to have to do those exam papers again, or these papers. But this is the January 2015 paper, and you're going to have to do this paper at some point, like a mock exam, and the exam conditions during the entire paper. All right, so this should maybe help you to get there and get comfortable with the questions, which is the whole aim. The whole aim, after to get comfortable, structure the questions and know how to approach them, and being familiar and so on. But by the time we get to exam, this field will very, very functional. Right? All right. Check. Are you still there? Can you still hear me? I lost contact from my phone.
Yes, sir.
All right. Okay. All right, let's go. So I gave you a number of questions to do on this paper. I deliberately left out some of them that maybe you could have attempted, but I say no, let me leave those for the time being. All right. So we're just gonna do the question that I told you to do today. For those of you who did it, you can just basically check your work, mark yourself, learn from your mistakes. And those of you who did not do it, you can also now go and do it. The video will be there and available. All right. So first question is a user calculator question. Work this out. And they want the example. So let's get the calculator. All right. So basically, I want to work this out. Put this in the calculator. I will exactly as it appears here. So 12.8 squared minus bracket 30 divided by 0.375 close bracket. That's what I'm getting. I'm just checking that what you have here is the exact thing that you typed there. 12.8 squared minus 30 divided by 0.37 and size 83.84 equals 83.84. What is it? All right. 3 marks for doing that. 3 marks. Use a calculator to get that. I don't know. I don't know if they maybe wanted to work it out step by step, work out that part first, work out that part separate. It don't make any sense. Because if you can use a calculator, it makes sense to use the full capacity of a calculator, which is to type this exactly as it is there. And so maybe this is just three marks. They want to ensure that nobody gets 0. All right. Next part, next question. All right. So this question says Mark spends 3/8 of his monthly salary of the remainder, and if he spends 3/8, then the remainder is 5/8. Let's make a note of that, right? But the total must be 8 parts. So 3/8 gone to housing, then the remainder is 5/8 of the salary. So of this 5/8, he's spending 1/3 on food. So it's 1/3 of the 5/8 he's spending on food. All right, and then he saves the rest. So let's look at it. It says calculate the fraction of his monthly salary spent on food. So food is 1/3 of the 5/8. Simple as that. But understand that the fraction spent on food is 1/3 times 5/8. That is 5/24. Simple as that. But go to that as a fraction. 1/3 of 5/8 of the salary. But okay with that? Students? Hello?
Yes, sir.
Okay. All right. So listen to me now. All I'm seeing is what you are seeing on the screen. So I don't know if you cut off. I don't know if you're still there. And so for me to know that you're still there and so on, sometimes from time to time I'll ask a question. And it's supposed to be an interactive class anyway. It doesn't matter of me just working on the questions and you just sit there and look. So if I say everything good, you're all right, you understand, somebody need to respond. Otherwise I can't move forward. But then I would not know if you understand, if you see what I'm doing, if you still, I remember I'm online now, and I'm not seeing everything. I am seeing what you are seeing. So I'm not seeing who's in the class, I'm not seeing that you're still there or anything like that. All right? So bear that in mind. If I ask a question, you need to answer, please. All right. All I do, open your mic, answer, and then close it back again. Next part now says calculate the fraction of the monthly salary that is saved. So he saves the rest, right? So he has 5/8 left after the housing, and he spends 1/3 of that 5/8. He spends 1/3 on food, and he saves the rest. So he saves 2/3 of the 5/8. That's what he saves. 2/3 of the 5/8. All right. So calculate the fraction of his monthly income that he saved. 2/3 of the 5/8 of the salary. Simple as that. That's 10. This can be simplified. 2 into this 1 time, 2 into this 4. Then it becomes equal to 1 times 5 is 5. 5 over 12. 5. Meter mic, please. Meter mic, please. That is it. What about that? Simple as that. Simple as that. All right. So a simple fraction question. We're going to another part. Remember, told you that these exchange rate questions can be done as ratio questions. Right? It's like a ratio. And a ratio can be multiplied or divided by any constant value or any constant unit of measure. Can be done as that, as a ratio. So it gives us this relationship, US $1 at bank rate. It's equivalent to Barbados $1.96. Right? So the BD means Barbados dollars. I want us to tell them the value of 700. So basically you want this side to become 700 and multiply by 700. All right, so let's need to take this ratio and multiply by 700. All right, so it's US $1 equals Barbados 196. But this side to become 700, we need to multiply everything by 700. Just gonna go straight for this one. So you get US 700 becomes equal to multiply this now by 700. Let's use over here. So it's 700 times 1.96, and that is Barbados dollars 1120. That is it. All right. Next part now says at another bank B, the value of the $700 is this. All right. So this is getting more Barbados dollars than that at bank B. It says calculate the value of $1 US at bank B. So basically what it is now is that you have this as a ratio now, and you now want this to become 1. So at this bank, it is US 700. That is now equal to Barbados dollars. 1386. And you want this to become 1. All right, so for it to become 1, we now divide this one by the same 700 to get this side to become 1. And this way, this is what it is here. And so this becomes US $1. So now we divide this number by 700 as well. So it becomes 1386 divided by 700. And we get 198, $1.98. Barbados dollars, 198. $1.98. So it's a higher exchange rate. This one, as we get more, the same $700. Yes. All right. And I think you got question. This is the question number 1. But good. Don't think I need to calculate that. Yes.
For question C number 1, you have the wrong thing for the Barbados one.
Barbados. Yeah.
Or at least I'm seeing 2 different answers for the 2 parts.
I don't understand. Wait, let me see.
Because for the first one, you have 1,120. And then now the second one, I see 1,386.
So let me show you the question. The question down here, up here, is talking about a bank A.
Yeah.
This is at a bank A. This is the exchange rate. Question is asking you how much at bank A would 700 Barbados dollars or 700 US dollars be in Barbados dollars. And so multiply this relationship by 700 here. So at bank A, $700 gives you that amount of Barbados dollars.
Okay.
All right. The next part of the question is a different bank, bank B. And at bank B, the $700 they're telling us at bank B is now this amount. So the $700 at bank A is this. For the $700 at bank B is that.
Okay,
They want us to tell them at bank B what is the exchange rate. So at bank B, they're telling us that the $700 here is this amount of Barbados dollars. That is it. So from this relationship, it is asking us now, how much would $1 US be at bank B, which is supposed to be a higher rate. See it?
Yeah, I understand now, sure.
All right. Maybe read the question. All right, cool. No problem. All right, next question. So this one is some algebra, right? It wants us to simplify this thing. So when you multiply indices, you add the powers. All right, so I'm multiplying these 2 things. So I can multiply the PQ by the P, add the powers, and get P to the 4th power. I multiply these 2, I add the powers, and get PQ to the 7th power.
Excuse me, sir.
Yes?
For the same question C1, when I multiply the $1.96 by 700, I got 1,372.
Oh, let me check my calculator. I put in something. Let me see. If I'm doing the right process, but maybe I entered something wrong. So it's 700 times 1.96. Okay, I made a mistake. It's supposed to be 1, 3. I don't know what I put in first time, but it's the correct figure. I entered the wrong thing in the calculator, apparently. I don't know what I entered. It's 1.96. Right, so that's a calculation. That is correct. I was doing the right thing, but I entered the wrong figure. All right, thanks for that. All right, and that's the beauty of doing the question as well. That is the beauty of actually doing the question. All right. All right, so down here, this is the answer for this one. We're good at that. So add the pause when I multiply these like terms. When there's no power on this piece, the power is actually 1. So 3 plus 1 is 4. And then when I add the powers on the Q terms, the powers are 2 and 5, they add to 7. Basically, then this is the answer right here. Very good. Are you okay with that?
Yes,
All
sir.
right. Yeah, that's here, they want us to express this as a single fraction. It's an algebraic fractions. We want the two denominators to become the same. So when the two denominators the same, I'm looking for the lowest common multiple of these two denominators, which is 10. But this one to become 10, I need to multiply it by 2. So if I multiply the denominator by 2, I have to multiply the numerator by 2 as well. But this one to become 10, I need to multiply it by 5. If I multiply the denominator by 5, I also have to multiply the numerator by 5. Another way to look at it is that you take this denominator and multiply it up here and down there. And you take this denominator and multiply it up here and down there. All right? You want the two denominators to become the same so that they're related. Then 2 times a right here is 2a. So it becomes 2a over this 2, 5 is 10. Plus, multiply these two numerators, and now you get 15a divided by the 2 times 5 here. Again, is 10. Now that they have the same denominator, they are related. The answer is going to have that same denominator. And you add the numerator values. 2 plus 15 is 17. From 17a over 10. That is nice and easy. Do it another way and get the same answer. Still good. All right. Next question. Wants us to factorize this. This one is kind of easy to factorize because all the factors of x squared is x and x. All right, I'm going to just do it in one step. All the factors of this x is x and x. Then you want factors of the 4 goes here and here. And those factors must be such that the far product and the near product add to this middle term. In terms of the numbers, you want factors of the 4 that add, always add, but this is a plus. When it's a plus, the far product, when this last value is a plus, provided the first value is positive, it means then that it is a sum of the far product and the near product that must give it the middle term. All right, so those factors are going to be 1 and 4. But then the far product is going to be 4x and the near product is going to be 1x. 1x. They add the 5x, which is the middle term. Then now, the matter of what sign do I put in the brackets now? Now, when the last value is positive, it means that the two brackets, the two signs in the brackets is the same sign in the bracket. And this tells you what they are. They are both negative. So this is negative, that is negative. You have to learn the shortcut of doing these things. And watch over the video, listen to what I've said. All right, check it. Far product and the near product must be about the middle term. Far product is minus 4x. The near product is minus 1x. We add the negative 5x. So that is it. Oftentimes these can be done in one step. You don't need to go through the AC multiplication and all that. All right? Practice. Next question wants us to factorize this. It's the difference of two perfect squares. But this can be expressed as a perfect square like so. Can be written as m squared minus 2n r squared. This has become 2n r squared. Then the difference of two squares, factorize this now become the difference of the two numbers, the m and the 2n. And the sum of the two numbers, the m and the 2n. So those are your factors right here, this expression. All right. Is it moving along? I want us to solve this inequality. By solving this, the same steps as solving 2x minus 7 equals 3. Transpose everything away from the x. It's the subject. Remember, with the inequality one, if you have to multiply or divide by a negative number, you have to reverse the inequality sign. So the first thing I'm going to do is move this 7 over here and add it. So like I'm adding 7 to both sides first. And when I add 7 to this side, same as transposing the 7 over here, I get 2x less than or equal to 10. The 7 goes over here, I do 3 to the 10. The sign stays the same, but I did not multiply or divide by a negative number. Do that with 2, I need to divide both sides by 2. All right, so next step is to divide both sides by 2. Because I'm dividing with a positive number, there's no need to reverse the sign. The sign stays as a less than. And so when I divide this side by the 2, becomes x less than or equal to divide this side by the 2 becomes 5. That's my answer right here. That's my solution. All right, part 1. Part 2 says, if x is a positive integer, what was it again? It was x less than or equal to 5. If x is a positive integer, a positive number is a number that is greater than 0. An integer is a number that's a whole number. So basically, they want us to list the values of x. So x would be equal to, I'm not going to put 0 because it's basically less than 5 was positive, meaning greater than 0. So it starts at 1, then 2, then 3, then 4. And then because the equal is on this inequality, we have to include the 5. Basically, that would be the list of values 1, 2, 3, 4, and 5. Positive integers. Positive are numbers greater than 0, so I'm not including 0. And integers are whole numbers. Basically, that is it. Very good. Very good at that.
Yes, sir.
Yes, sir.
All right, good. Let's continue. All right, here now, I'm giving this expression. This is some physics formula for 2 L over G, I don't know, L over G. I don't remember which formula this is. All right, so it says pi is 3.14, L is that, and G is 10. I think this is, I don't remember what formula it is. But anyway, I want us to work out the value for this. So basically substituting these values inside here. All right, so it's going to be equal to 2 pi root L over G, going to become 2 times the pi is 3.14 times the square root of the L is this value, 0.625 divided by the 10. Divided by 10. So about 2 times 3.14 times square root of a fraction 0.625 and the calculator. Same thing, right? That is 1.57. 1.57. This is not calculated on that line only, 1.57. Yes. 5 elementary. But you know what formula this is again? What formula is it? Value equals 2 pi. This is acceleration. Let's about let's somebody recognize the formula? This is a physics formula. I don't remember which one. All right, so I did not want student number 3. And I did not want you to go. Did I tell you to the number 4?
Yes, sir.
Hold on, I've said this part. One second. One second. Hello? Yes? No. Uh-huh. Or 2 deposits, 2 down payments, 2 down payments. Oh, you got the down payment twice. Yes. Yes, yes. Oh. Yeah, man, I saw that, I saw that down payment came out of. No, I think we're finished. We have gotten everything. All right. I tell you what, I could just clear up the one that you have sent. Just clear the one that you have sent and then we'll start with. No, no, let me tell you what happened. I think what happened is that the total that was placed on the books. When I sent you the email, I showed you total that was the total that was used. When I sent the email, I put it in red. The total amount was the total. Hold on now. Hold on now, Aisha. 09 and 011, right? But what happened is that the total, the wrong total was picked up as a total for the invoice. It's just that I'm in a class now, Is it trying to sort out now? But Aisha, if you look at the invoice, right? Let's look at the invoice. All right, so hold on. So I'm going to talk about the figures that are on the invoice. Students, just excuse me one second. Something very important. Let's give me a second, please. So if you look at the invoice, right, there are 2 totals on it. There's the first total. The first total is the invoice total, overall invoice total. And no, look at the invoice that I sent you.
Yes, sir.
Look at the invoice that I sent you. The copies of the invoice that I sent you. Let me open this card. Students, just give me a second, please. Just give me a second, please.
trust us to be better. The truck is expected to remain below days 24 hours. Expect weather conditions to become clear tonight. Minimum temperature expected for Kingston tonight, 24 degrees Celsius. Minimum temperature expected for Montego Bay tonight, 24 degrees Celsius. And that was the weather report. We now to the Costa Rica.
All right, students. Sorry about that, but I'm still at work and it's end of year. And there's some stuff that we have to close and clear when it comes to end of year. All right, so pardon the interruption. All right. So I was asking if I told you to do this question. Did I tell you to do this question? I don't remember if I told you to do number 4. Did I tell you? Huh? I told you to do number 4, yes?
Yes, sir.
All right,
Yes.
good. Now let's do it then. All right, so it says an electrician charges a fixed fee for a house visit, plus an additional charge based on the length of time spent. So you have a fixed fee and you have a variable fee. All right. All right. It says the total charge Y are calculated using this formula, where X represents the time spent on the job. So this is almost like just common sense, you know. This is a formula, and this is a fee charge, and this is the time. It means that this is the time, this is the variable part of the charge, and this is the fixed part of the charge. So this is the fix. Remember, you know, this is the time spent. X is the time spent, and you just reach, and the time is 0. Okay, you just reach. Means that there's no variable charge, so you're only paying the fixed charge, which is the amount that you pay for reaching, for just arriving at the location. Then now, right, based on the time spent, he is now paid an additional variable charge, and X represents the time in hours spent on the job. So basically, based on this formula, he's paid $40 per hour. $40 per hour, because X is the time spent. So if he spends 1 hour, he gets paid 40 times 1. He spends 2 hours, he gets paid 40 times 2. That is after he's paid this fixed amount. If you can understand that in this formula, the question becomes a lot easier to deal with. All right? That's what does that mean here. It says complete the table for the equation only. All right, so this is a linear equation, guys. So this is like coordinate geometry with a linear equation, but they're applying it to a real life situation. So people ask all the time, oh, linear coordinate geometry and stuff that we do in class related to real life. Yes, this is a good example of that. Because we're using a linear equation to calculate somebody's charges for a job. All right, so I want us to complete the table. So these are the hours spent, So basically adding $40, to these, But every time he spends an additional hour, he adds $40. You can look at it that way. So you can add $40 to this. You can know the answer right away. Just add $40 to this for the additional hour that he spends. That's 155. If you want to put 2 in this formula, it's going to be the same thing. Look, on the calculator, 40 times 2 plus 75. See, 155. Then you can add another $40 to this for the additional hour. Or put it in the formula, and it's 40 times 4, and it's 235. You just add another $40 to this. Hey, mute my, who is that? Wait. All right. All right, so that is it, guys. That is the table completed. Next part wants us to use the grid on page 13. All right, we set a scale, but it's a scale of 2 centimeters represent 1 or 1 x-axis, 2 centimeters of $50 on the y-axis. Plot the points. All right, plot the 7 pairs of values on the graph, and then draw a straight line. So that's straight line graph. You basically drawing that graph of that straight line. All right, so let's see if it can be done here. All right, so there are no negative values in this. There are no negative values in this. So can basically just use a graph from down here. Use this as the horizontal axis. And use this as the vertical axis. There are no negative values. Okay. Then it says at scale 2 centimeters to 2 centimeters to 1 hour, 2 centimeters to $50. All right. 2 centimeters to 1 hour. All right. So 1 hour, 2 hours, 3, 4, 5, 6, or 5 people. 6 hours, yes. And then 2 centimeters to 50. But we do have to start at 0 now, guys. I have to make sure that this all can hold on the scale. And he's starting at $75. I don't know that we have to start at 0. All right, at 0 on the scale. You have to be able to hold at 315 in terms of the money. And it's $50. So let's just kind of check it, $50. So it's 2 centimeters to $50. So it's 4 centimeters to $100. So let's see. So this should be $100, $200, $300. Okay, no problem. So this is $50, $100, $150, $200, $250, $300, and here would be $150. All right. So if you look at the scale now, look at this line. That's kind of much. All right, so look at the scale now. It is 10 lines between 0 and 50. So it's 50 divided by 10 lines. Tell you what each line is. That is 5. This line is 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So you don't want to know what each of these lines is. Each of these lines would be, each of these lines is 5. Down here, it's 10 lines again. That is how you 1 hour. So, well, you're not going by hours anyway, but this would be 1 divided by 10. So each line is 0.1 hour. So 0.1, 0.2, and so on. Let's put it here. Each of these little lines is 0.1 hour. All right, might need those numbers. All right, let's go now. So plot in the graph. So the first pair is 0.75, 0.75, and it basically increasing by 40, increasing by 40 here. So look at it that way. So 0.75 starting, let's put a part in there, let's do the graph in there. 0.75, the 75 will be right here. Halfway between 50 and 100. They're going up by 40. All right, so how many lines is 40? That's 5, 10, 15, 20, 25, 30, 35, 40. That's the next line, you know. All right, they're going up by 8 lines. Yeah, by 8 lines. So coming on this for 1 hour, and you're here, you're going 5, 10, 15, 20, 25, 30, 35, 40, right there, the next one. You're coming over to here, for the next, to start here again. I'm going to buy another 40. That's 5, 10, 15, 20, 25, 30, 35, 40, right there. And for the next hour, coming across here to start, and then going up again, 5, 10, 15, 20, 25, 30, 35, 40. And then we're up by 40 again. Come across to here. That's all. 5, 10, 15, 20, 25, 30, 35, 40. Right here. Another 40. That's the line, you know. Expanding. Let's bring it the easy way, guys. 5, 10, 15, 20, 25, 30, 35, 40. That's what this corresponds to. Let's make sure. This corresponds to 275. Let's check in if it is correct. 5. Let's check if it is correct. 5, 275. Let's see. 5, 275. There you go. 5, 275. So I'm confident that we are correct on the right trajectory. All right. Let's go by another 40 at the next hour. Come across it here. 40 again. 5, 10, 15, 20, 25, 30, 35, 40. You see, I've done it without having to look at the table, recognizing that I'm just going up by 40 each time. So that is a straight line. So I didn't have to go back and look at the values on the table. We learn to do the mathematics the easy way. All right. So I need a straight line through those points. Basically, use your rule and do it. Don't do it freehand like me. I'm just going to draw it with my free hand. This device. That doesn't allow me to draw straight lines. That is it. But good at that? But okay?
Yes, sir.
So,
All right, good.
Yes, sir.
Notice that I did it without having to look at the table, recognizing it going up by 40. All right. Every hour I go by 40. So next one says no, use a graph. And watch me now, because it says use a graph, you have to draw lines on your graph to show that you use a graph. See? In bold letters. So to show that you use a graph, you're going to have to draw lines on a graph. It says use a graph, determine the total charge for spending 4.5 hours. So yeah, you're going to have to go to 4.5 and go up and get the time. But because you can calculate it, I would calculate and see what the answer is supposed to be. Remember, it's y equals 40x plus 75 is the formula. So I'm going to work it out and see when the x is 4.5. Let's work it out. 40 times 4.5 plus 75. I'm supposed to get 255. That still have to go and do it on the graph. Let's draw those lines in purple. So I'm going to 4.5 hours, and the answer is supposed to be 255. Let's put it on the graph. 4.5 hours. So this is 4 hours, this is 5 hours. 4.5 is right here. Right here. It's 4.5 hours. So come up on the graph. up on the graph. And you read it across. That is the time. That is 2:55. That's how you show that you use a graph. Those lines that I've drawn in purple. So I can just write my answer here now. This is 2:55 with $sign on it. Without charge, 2:55. Next one, the time in hours spent for a job, $200. So again, I can calculate it by putting this equals 200. So in this case, it will be 200 equals 40x plus 75. Subtract the 75 first, get 325, no, 225. 225 equals 40x. Then divide by the 40. The x is 225 divided by 40. That's what time that is supposed to be. So it's 300 minus 75, 225, and then equals and then you divide that by 40. Just checking what the answer is supposed to be. 5.625. But if you give them 5.6 or 5.5, they'll accept it because they use it in your graph. So I have to give them an answer close to that. But to show you do it on the graph. So you're coming up to 300 on the graph and you plot down to see what the time is. At 300. Let's go. Come on the graph, it's 300. 300 is right here. You come across on the graph at 300. And I come to this line and it's right here. And I'll come down here. I think I'm going to end up giving them 5.6, which is good enough. That's it. 5.5, 5.6. I'm going to write 5.6 because if we give them 5.625, they're going to know that to use a calculator. This question on your graph, so you give them 5.6. Most I will do is say approximately 5.6 here. Here, I'll maybe say approximately 5.6 hours. That's it. And then the fixed charge. Fixed charge is easy. That's when the time equals 0. That's when x equals 0. That's $75. Right? But let's say use a graph. Come down on the graph. Let's mark it right here. So this is my fixed charge. Just to show them that I use the graph. Like it said, use the graph. That's my fixed charge right there. And that's when x equals 0 and no time has passed. That's your fixed charge. That is it. All right, so I've shown that I use my graph to get my answers. Here it is. Limited. Draw lines on your graph to show how your answer C1, well, C1 and C2 they really wanted are obtained. That's it. All right, so even if they did not tell you this, you would still have to know that you have to draw those lines. All right, that wasn't a bad question. But good? Are you okay with that?
Yes, sir. Yes, sir.
So I have this question marked already. I'm sure that I would have given this. Maybe we did it sometime already. That's already marked. I must see if I get them. Let's do it again. Scratch. Right. Let's go. All right. I would have given you this question. So diagram below shows LMN and PQR after transformation. And what I've never seen about this question, I don't like the fact that the letters are different. So for the prime thing, right? We must know that it is L to P, first letter to the first letter, M to Q, then alphabetical order. All right. And it's N to R. All right, everything important, guys. We're not taking anything for granted. All right. So we're down here. All right, so it's P, Q, R, and L, M, N. All right, which one is the image? So it's this one, down to this one. All right. So everything is the same, so that's clearly a translation. It's clearly a translation. How many units? Just usually choose 1 point. For example, this went to this. Check the scale if 1 centimeter is 1 unit, or if it individes a 1 unit, yes, there. This is just a vertical movement downwards. 1, 2, 3, 4, 5, 6. That's a translation, 6 units downwards. That would be 0, -6. All right, that's what they asked us now. It says right now the coordinates of n. N is this point right here. That is 4, 5, 4, 5. So n is the point 4, 5. Then it says on the grid, draw FGH, the image of LMN, a reflection in the y-axis. All right, draw FGH, the reflection of LMN in y-axis. Mute your mic, please. Mute your mic, please. All right. So I want to reflect the LMN in the y-axis. All right. Remember, instead of saying y-axis, we could have said a line x equals 0. I've seen them do that from time to time. All right. So reflecting in the y-axis. So reflecting this in the y-axis. Remember, the y-axis is now your mirror line. That's a red line. Remember, you do reflection 1 point at a time. Image distance equals object distance. So L first. What's it again? L going on to FGH. Going to FGH, L, M, M. So get the letters right. All right, so L first. L going to F. 1 unit to the mirror line. No, sorry, 2 units to the mirror line. 2 units on the other side here. All right, so we're coming to here. That's where F is. Then LM, M next. It is 2 and 2, 4 units. It's gonna go same 4 units on the other side to here. And that is where second letter G would be, G. And then the N is again 4 units, 1, 2, 3, 4. Going 4 units on the other side. So it's going right above the M. So it's going right above the G. That's where the H is, up here. That is it. So that's where the H is. So this is my image triangle. Now do your reflection 1 point at a time. Don't reflect the entire triangle all at once. All right, that is your H triangle. That's an easy. All right. That's it. Next part says use the vectors notation. Describe transformation which maps element onto P prime, P prime. That's translation. I want us to use this vector notation. So it's gonna be a translation. Six units downwards. Downward. Given by, let's say use vector notation. 0, -6. That's it. Right? This part said, complete the following statements. So PQR maps onto FGH by a combination of two transformations reciprocity. PQR to FGH. PQR, FGH. The value reflection is sanitized. We're going to have a translation up there, so 0.6, followed by reflection in the y-axis. I'll put the reflection first, then the translation. I think it's leading us, right? So that's what it says. So PQR is mapped to FGH first. PQR by combination. First, PQR maps to LMN by a translation. Parallel to the y-axis. I'm going to put the values on the translation next. By a translation. Translation. Six units. Parallel to the y-axis. Means it moves vertically. Parallel to the y-axis. So when movement is vertical, they say it is parallel to the y-axis. When movement is horizontal, they say it's parallel to the x-axis. All right. Then LMN is mapped to FGH. See? LMN up here now is mapped to the FGH by a reflection in the y-axis. Let's see what it says. By a reflection in the y-axis. Or we could say in the line x equals 0. The y-axis is x equals 0. Down here now, it says PQR and FGA are congruent. Congruent triangles are triangles that are equal in every way. State two reasons why they are congruent. All angles equal and all the sides equal. All angles equal and two triangles equal and all the sides are equal in length. All sides equal in length. The same three, they have three equal angles. Same three equal angles. Don't have to say that. The three angles are equal, and the three sides are equal length. That's it. If you say all angles equal and all sides equal, you'll accept that as well. That's it. But good at that? But okay?
Yes, sir.
Sir, can
Yes,
you
sir.
repeat the reasons for the congruent question?
When two shapes are congruent, it means that they have everything equal. The angles inside are equal, the length of the sides are equal, the area equal, the perimeter equal, everything about them, they're just identical in every way. That's what the word congruent means.
So
Identical.
sir, if we put any reason, like anything that says a specific feature of the triangle are the same or something like that, we'll get it right.
I think this is what they're looking for. This is the textbook definition of congruent. All sides
Okay.
equal, angles equal.
So in this case, would the definition that Luke gave count? Just any angle being equal to the other angle. In this case, would it work?
What did you say? What did you write?
Basically the same thing. Wait, I'm on my phone right now, so I have to go on it.
Yeah, man. Once you say anything that is like this, you get the mark. What I'm saying going forward, I'm telling what to say going forward. When you see the word congruent, tell them this. Tell them that all the angles are equal on the two shapes and all the sides are equal. That way there's no ambiguity. It's clear and obvious what it
Yes,
is.
sir.
All right. So going forward, when you see the word congruent, especially with respect to two triangles, just say the two triangles have three equal angles, same three angles. and they have the same three sides in there. A way of saying that is to say that all angles are equal and all sides are equal. All
Yes,
right?
sir.
And remember, not only triangles that can be congruent, you have congruent shapes. If you have a square and another square, and they have the same sides, 4, 4, 4, 4, and this is 4, 4, 4, 4. Then these are congruent squares. These are congruent squares. But they have all the dimensions equal. All the dimensions are the same. Angles and sides are the same. So even though these are oriented differently, doesn't matter. Three angles in this is the same three angles in that. The three sides on this is the same three sides on that. That's why they are congruent. Doesn't matter how they twist and turn or anything like that. All right? That is all right, beautiful. And I would not have given you this question, but it's a question that you have to measure. This is a scale drawing. The question wanted you to measure and state the length of this. So I could not have given you this one to do. I think we're skipping this one. This one, we wouldn't do this one yet, because we don't do the topic of circular measures yet. That's coming up soon. I would not have given you that one either. I would not have given you this, I would do the statistics yet. I would not have given you this one either. We don't do the patterns yet. All right, sequence patterns and shapes. I'm gonna do that patterns later on as well. But I would have given you this, and we have already done the topic of function. This one gives us these two functions, f and g, and it wants us to find f of 7. You plug 7 in f function right there to do this. So this becomes equal to 5 times 7 minus 4 divided by 3. Well, this is 35. 35 minus 4 is 31. 31 over 3 is the answer. That's an easy. Next one wants an expression for f to the minus 1 from this function. All right, I want f to the minus 1. Let's start by saying f equals, what is it again? 5x minus 4 over 3. 5x minus 4 over 3. Basically, I want this to become a subject, but we can inverse it first. All right, so I'm going to inverse it first. This f is going to become x on the inverse function. And this x is going to become f to the minus 1 on the inverse function. And then we're going to make this a subject. Take this 3 and multiply it across here first. I'm going to get 3x equals 5f to the minus 1 minus 4. Then next, put it up here. All right, so this has become that. We'll multiply across the 3. Then, to leave this as a subject, I'm going to take this 4, add it over here, and then take this 5 and divide it under. So I'm going to get 3x plus the 4, and then divide under the 5. That is f to the minus 1. And that f to the minus 1 x really. This is the answer. This is the f to the minus 1 on this. All right, that next part says I want g of f of g. F of g means g into the f. Let's write them out again. Okay, from the g was. Let's write them again and copy them. Remember that the f is 5x minus 4 over 3. The g is x squared minus 1. Copy this down. For the substitution. So these are two functions. And I want this f of g means g into f. Again, all of this g, bring it into the f right here, whether it's That's how we put G in there. So the f of g of x will construct it. It's 5 times all of the g, which is x squared minus 1, minus back this 4, divided by 3. Let's just simplify it. 5 times this x squared is 5x squared. 5 times this 1 is minus 5. And then minus 4 makes minus 9 all over 3. And that is it. That's the answer. You can't just divide this part alone by the 3, guys. No. You have to be able to divide each of them by the 3. You can't do that. I'm going to leave that as an answer right there. That is it. Very good?
Yes, sir.
Yes, sir.
Yes.
Good. Next part is a quadratics. What's this function here? I want us to complete the square. We're going to use x dy t as we always do. So you're going to write that the f of x is going to become a into x minus xt squared plus 5t. T means turning point. This is the x value at the turning point. This is the y value at the turning point. Know that even when I put a plus in here, I'm using x minus xt. When we use that method, the xt, this value xt, straight go to red. It's minus p over 2a. What is the a and the b? A and the b are coefficients in the standard form. In the standard form, the a is equal to the coefficient of x squared, which is 3. The b is equal to the coefficient of x, which is 6. And the c, the constant term, which is that negative 2. So using this a and this b down here. All right, so this becomes equal to minus the b is 6 over 2 times it is 3. It becomes negative 6 over 6, which is negative 1. Because my xt is a positive, is a whole number, I'm going to find yt by substituting it back in the function. So you can do it without using the formula method. So the yt is going to become 3 times minus 1 squared. So now put it here first. Plus 6 times minus 1. That's when I put it here. And I'm subtracting this 2 next. So I'm finding yt using this method. That becomes a positive 1. 3 times positive 1 is 3. That's become a negative 6. And then minus 2 more. So it's really 3 minus 8. 3 minus 8 is negative 5. So xt is this value coming here. Yt is value going there. All right. So my expression becomes that f of x becomes equal to the a. The a is 3 into x minus, and the xt is a negative 1. It's minus becomes a plus, so I can turn it into a plus. Don't forget the square, and then the plus yt, negative 5. So I'm going to write minus 5. That is it. This is my answer right here. Then it says, it's otherwise state the minimum value. The minimum value is the yt value. It's the yt value, which is negative 5. That's the minimum value. Right? Of the function is always the yt value. Negative 5. One more for that. And it says state the equilibrium box of symmetry of this function. It is always x equal to xt value. The value is negative 1. So the equation of axis of symmetry, i.e. that is x equal negative 1. That's the equilibrium of axis of symmetry. Next part now says we have to sketch a graph and show y-axis intercept and the minimum points. All right. So the minimum point at this part. So the y-axis intercept is your C, is your this value, your -2. The minimum point is xt, yt, which in this case is -1, -5. And the graph is going to have a smile shape for the A positive. Right? So let's sketch that y-axis. Right? So this point, -1, -5, negative x value, negative y value, sum it down here. So it turns down here. Like well, I say x at -2. -2 would be on this part of the y-axis, sum it down here. When that smile that turns here and crosses down here, that's to be a smile because the square term is positive. So you turn down here, cross down here, x like this, like that. It's not to scale. All right. Now that you know this, right here, the y-axis is your -2. And this minimum point is down here. Here. -1, -5. It's a sketch. We want the axis of symmetry, it will be this line. X equal -1. We want the roots of calculate these two x values to get the roots. That's how we create a whole sketch. Sketch of y equals 3x squared plus 6x minus 2. Is it done? Very good.
Yes,
Yes,
sir.
sir.
All right. Beautiful, beautiful, beautiful. All right. Soon we will do this question. Quick and fast. You don't yet know to do it. And this one as well down here. Coming soon, very, very soon. So for starting back on Sunday, learning the topics, doing the topics that will allow us to answer this question. Sine rule and cosine rule. And then this week we will circle some theory to that question. All right, so we'll be doing number 10 from next week. Okay? Number 10. All right. This one wants us to write this pair of sum of the equation as a matrix equation, HCD equation. So it is simple. X followed by y, two equations, which is that, which is good. And so the HCD equation becomes 2 by 2 matrix and a column matrix XY equals a column matrix with these values. With the 1, 6. Then coefficient of this side going here. So it is 3 and 2, 3 and 2, 5 and 4, 5 and 4. That's an HCD equation. So basically, this is the A, this is the X, that is the B. It says use a matrix method to find XY. So trying to solve for this. Then the inverse of this goes in front here. What's going to happen is that this is going to be that x becomes equal to 8 to minus 1 times b, coming from ax equals b. So the inverse of the b, because it is on front on this side, the inverse goes to the front on the right side. That is how we have this. So to find the xy, that's what we need to set up. All right, so let's write it. On this equation, the xy, it's going to become the inverse of this 3, 2, 5, 4 to the minus 1. The inverse of this one times the b to the minus 1, 6. We need to work on the inverse of this matrix, which is 1 over the determinant. What's the determinant? The determinant is this product minus this product. So this product is 3 times 4 is 12, minus this product is 5 times 2 is 10. The determinant is 2. Let's put it here. The determinant is just 2. So multiply that now by the adjoint of this matrix. So we can interchange these two values. The 4 goes here and the 3 goes here. Leave these 2 on the second diagonal. Leave them where they are. Change the sign. So this 2 stays where it is and becomes a negative 2. This 5 stays where it is and becomes a negative 5. Multiply that now by this matrix. Minus 1, 6. Yes, right. All right. We want to multiply out this part first. 4 divided by this 2. All right. So it becomes 1 over 2 times a column matrix. 2 values. So we are now multiplying these two matrices to get here. And we multiply the rows of the first matrix by the one column. We get a column matrix with 2 values. So this first value is positioned in the first row and the one column. So to get it, we have to multiply this first row by this one column. I multiply a row and a column by multiplying the first element in the row, the first element in the column, and then the second element in the row, and the second element in a column. We add those results. So it's first element times first element, second element times second element, first element times first element, second element times second element. It's 4 times negative 1 and negative 2 times 6. 4 times negative 1, negative 4. And negative 2 times 6 is negative 12. That is the first value. And then the second value here is positioned in the second row and the one column. So to get it, you have to multiply this second row by this one column. I multiply the same way again. First element times first element. Second element times second element. First element times first element. Second element times second element. Negative 5 times negative 1 and 3 times 6. Negative 5 times negative 1, you have positive 5. And then 3 times 6 is 18. It becomes then that we're working on 1 over 2 times this now negative 16. And this becomes what? 23. I'm just checking by the numbers, guys. I'm just checking by the number. I like to get when it is about 3, 6, and 8. Yeah, that's 23. We apply the half. Apply the half. This becomes negative 8. This is 22 over 2. 22 over 2. That is the x and y. We can leave this as the answer. The value is explicitly in purple. So the x is equal to negative 8. Y is equal to 22 over 2. That's what I got. So, oh, I made a mistake. See, I tell you now. It's a 4 and I have a 3 right there. Nobody saw it. So I kept looking at the numbers because I know these questions I like to give you a whole number of values as the answer. So it's a 4. Not a 3. Why did I write a 3? I don't know. This is supposed to be let's just check this out. Oh, still coming out. Alright, so still getting sure. Oh, it's right, man. It's right. I'll switch them around. That's right. That's right. I have to switch them around. It's correct. I have to switch them around to get that joint. That joint is a half. And I switch around to 3, 4, and I get 4, 3. It is correct. It's correct. My mistake. To switch them around and put in the inverse here. Inverse is. All right, that's it. That's it. What a good?
Yes,
What a
sir.
good.
Yes, sir.
Yes, sir.
Sir.
Good, 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 good.
So just to double check, right?
Yeah.
What before you find the okay, so after you find the determinant and you would multiply the matrices before you multiply them by the fraction.
Yeah, I normally say work out these values first by their whole numbers before you apply the fraction. As for example, if I apply the fraction to this, I'm getting 5 over 2 or 2.5. If I apply the divides by the 2, getting 1.5 or 3 over 2. So just to make the calculation easier, I usually leave the fraction here for last. I work out these with the whole numbers first to get this matrix. And when you finish that now, then you divide each of the values by this determinant here.
Okay,
I
that's
always leave the fraction for last. Yeah, leave the fraction for last. All right, good. All right, next question. So the diagram below shows two position vectors, OR and OS. And it was these 2 points, that is R, 6, 2, CSEC minus 4, 3, S. So they set this kind of question quite frequently, right? Almost the same kind of diagram. Then they want us to tell them the vector OR. So since we know the coordinates of R, there's no calculation needed, but it's they have the same values. So this one is just simply 6, 2 with the same values. Because R is the point 6, 2. Similarly, if we mark again OS, OS again going to have the same value as the point S. Therefore, 3. Therefore, 3 plus S is the point, negative 4, 3. No calculation needed. All right. See, there's one mark that expect to get 4 parts right. Then they want the vector SR. Now, the SR using calculation is 4 times the last minus 4 times the first. R is the last, so it's 4 times the last, OR minus S is the first. So we can calculate it that way, which then becomes the OR. As you can see, it's a 6, 2 minus the OS is a minus 4, 3. So this becomes equal to, put it here. This minus becomes a plus, so really 6 plus 4 is 10. And then it's 2 minus 3 negative 1. Now what we can check if to go from S to R is really this for true. This means 10 to the right and 1 down to go from S to R. So you can kind of check it, 10 to the right and 1 down to go from S to R. Here, from S to R. Answer the single 10 to the right and 1 down. Let's double check that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right, 10 to the right, and 1 down, 1 down. So the calculation and diagram match, so we're good to go. Know that this answer is correct. Diagram showing the same thing. Next part says we have to find a modulus of OS. Modulus is just a link. That is OS again. OS is, remember now, negative 4, 3. The answer is 5 and a Pythagorean triple, a 3, 4, 5 triangle forming. So remember now, the length is how long is this line. That's what the modulus is in it. So the minus 4, 3 means that this dimension is 4. And this dimension is 3. That 3, 4, 5 triangle. So this answer must be 5. This length is 5. That's a modulus. OX, that length is going to be 5. Right? So you know that the alpha is 5. But then we can also show calculation. Then it's a modulus of OX in this one. Is the square root of this side squared. Let's put 4 squared because the negative 4 squared and positive 4 squared is the same. Plus this side squared. 3 squared. That's going to work out to 5 MD. And modulus is length. So I like to put the word unit beside it. As a modulus is a length. This is modulus or magnitude or size or length. That's what this is. How long is the vector? All right. Then here now it says OT is the meter arrow on top. This prove that this thing is a parallelogram. Show that a parallelogram, show that it satisfies the properties of parallelogram. I like to ask students to select that. All you need to do is show that the opposite sides are equal vectors. Well, let's put this on the diagram to see it. Now, OT is 2,5. Therefore, means that T is a 0.25. OT is a portion of it of T. So T is a 0.25. Let's put on the diagram so we can see what we're working. 2,5. So 2, 5, 1, 2, 3, 4, 5, right here. Right, so T will be right here. So they want to show that this thing now is a parallelogram. So you do that. You have to show that this side and this side have equal vectors. So you want to show that this side is ST. Let's write it down. ST is equal to the R. So they need to show. And I also want to show these two sides. These two sides. This side, this side. Yeah, equal vector as well. That is that RT equal to OS. We need to show those two things to show that it's a parallelogram. All right, copy it down. That's what we need to show. All right, let's go on with that. What is a parallelogram? I'm gonna say show this. Need to show this thing before I draw a parallelogram. Now we have these already, the OR and the OS. Let's write them down. So the OR, remember, was a 6-2, and the OS, 4-3. We need to find ST and find RT. So that they equal to these two things we start. Let's do the ST first. So now ST is OT minus OS, which is 2,5. Well, OT is 2,5 minus OS is this one, negative 4,3. Work this out. 2 minus 1 become like plus right here. There's 2 plus 4 is 6. And then the 5 minus 3 is 2. And this is your OR. So that's on that first part. Right? So this is OR. For that first part. Pick. Second thing we need to show now is the other one, right? So that's and another thing we need to find out is RT. RT is OT minus OR. And OT again is 2,5. The OR is 6. 2, right? 5, 6, 2, so this now becomes 2 minus 6, we need to put 4. And 5 minus 2 is 3. this vector is individual orders. So you now have again another R to move at the orders. And RT is actually the orders. Pick. So I've shown both things. Shown both things. So from Jonathan Cole, based on all of this. And so therefore, shown O S T I is and that is that. And not this test. That is it, guys. That is it for today. See you on Saturday. More math equals better math. You know I'm gonna send you more work tomorrow. For those of you who got anything wrong on this paper, you need to redo it. Anything you did not do, you need to now go and do it. I'm gonna send the video right afterwards. You can go back and look at the video for anything. All right. So just look back at anything you're not so solid with. Look back at the video if you want the issue. Send me a message. I'll send another paper for you to do tomorrow that we can work through on Saturday. Then we'll start back with the lessons, learning new material, everything we've been doing over the holidays, revision, everything is revision. All right. So we're going to start learning new material again Sunday morning. All right. We want to finish everything on the syllabus by March, all the main things by March. And then we go into the exam preparation phase of the program. So far, so good, guys. So far, so good. Just keep practicing. Keep practicing. More maths equals better maths every time. Okay, everybody? Are you good? All right. So
Yes, sir.
I send the paper to them coming up, please. To the papers, please. Just do all these papers, you're gonna have a fun time in the exam. Mr. Paywa, I'm very happy to see you online. Very happy to see you here today. This time. All right. Very good. Very all right.
Yes, sir.
Put the work, put pen to paper. Put pen to paper. Put in the work, you will get the results. All the people practicing all the time and doing all the assignments that I send you. You're gonna have a fun, easy time in the exam room. Guaranteed without a doubt. Without a doubt. You're gonna go in that exam room with me and you're just gonna have fun. Just working through those questions and getting everything right and what you like. We still have time for person to catch up and start to have the right attitude towards the subject. And that attitude is just basically to all the work, practicing, practicing, practicing. All that is required in the subject. Practice, practice, practice. All right. I'm gonna end it now, guys, and we'll see you. I'll see you on Saturday. Our online class again on Saturday. And I'll send a paper for you to do. All right, keep practicing. Bye, everybody.
Bye, sir.
All right, cool.
Bye, sir.
Bye-bye, bye-bye.